In this video, we'll discuss wave reflection, and we'll build a ray diagram like this for reflection. But first, we need to discuss what a normal line is, because we'll use that in the diagram. A normal line is a line perpendicular to a surface. You have a straight line here, horizontal. I'll call that the surface. We're going to draw a line perpendicular, so I'll draw that line right there. And of course, that's 90 degrees. And we'll call that a normal line, not rocket science. It's just a line perpendicular to a surface. There must be a surface involved for there to be a normal line. A flashlight sends forth millions of light rays, millions. We're going to use one single ray to demonstrate how reflection works. So we'll use one of those millions. I've only drawn 6, but there are millions there. We'll use just one. Alright, so here, to start our diagram, we're going to use a mirror down here where the reflection is going to occur. We have to draw a normal line to a point on that mirror. So there's our point, there's our normal line drawn to 90 degrees, and we're going to use that in our ray diagram. Alright, so there's the line, here's the mirror still. Now I put blue and red here. We're going to call this side the incident side. The word in is in there. Yeah, a ray is going to come in here. And that's called incident side. Once it bounces out and reflects, we're going to call this the reflected side over here in red. So here's our incident ray. A ray comes in, a single ray, like I said earlier, comes in, it's going to hit right there on the mirror. We could call it the incoming ray, but they use this term here, incident ray is coming in. Now, of course, that's going to bounce off that mirror, isn't it? It's going to travel back as a ray called the reflected array. And that makes sense, right? It's after reflection. Good. Incident ray, reflected ray. Now, here's where the normal line comes in. We're going to call this angle here between the incident ray and the normal line. We're going to call that the angle of incidence. Note we don't use this one down here. We could, but the convention is to use this. So that's why we needed that word. The angle of incidence from the incoming ray to the normal line. It's not going to surprise you that we have a very similar angle on the other side, on the reflected side, and that's called the angle of reflection. Again, between the ray itself, in this case the reflected ray, and the normal line. Not down here, it's up here on top. Your video code is incident. Incident, E-N-T. Now, what happens is, if you have a 40-degree angle of incidence, you have a 40-degree angle of reflection. These top angles are the same. And that's the key thing to reflection. It's really the only tricky, well, it's not tricky, it's the only thing to know, really. The rays come in here to this point, and there's an angle here to the normal line and the ray. Whatever angle of degrees we have here, we have the same one here. The top angles are the same, aren't they? That's really all that's going on here with reflection. I changed it here to increase this angle. I brought this down less steep. The incident ray now forms a 50-degree angle between the ray and the normal line. Then, of course, it's going to bounce out and have that same 50-degree angle on the reflected side. Now, what do you think? Will this work just for visible light or for all EM waves? Now, we had all the way from radio to visible to X-ray to gamma. We had 7 different kinds. What do you think? Will this reflection work just for visible light or for all the EM waves? Well, I hope you said this. All EM waves. An X-ray would bounce off this the same way. It's a light ray or a gamma ray. Radio wave, they're all the same. They all will bounce off. Just like this. All the EM waves will work that way. How about sound? I've returned to my 40 degrees here. What do you think about sound? Do you think sound would reflect? No, sound's not an EM wave, is it? Sound is a mechanical wave. It needs air or something like air for a medium. So it's not an EM wave. But will it reflect? Sure it will. Here it comes. Sound comes here, hits that point, bounce right out. Same angles here. I haven't labeled them, but it's just the same. And in fact, there's a name for that, such a reflection, and that's called an echo. All right, that's it. To summary, really what it comes down to is equal angles from the normal line in and out. We got an equal angle there, 40 and 40. That's the main thing, okay? The incident ray comes in, hits, bounces out, same equal there, same angle there. These are all EM waves here. The rays of all EM waves reflect. And the last thing is that the sound waves also reflect. These are sound waves. And they work just the same way. Okay, bye.